Okay, this is Physics Chapter 11, Problem 56, and it reads, the winning time for the 2005 annual race up 86 floors of the Empire State Building was 10 minutes and 49 seconds. The winner's mass was 60 kilograms. Part A reads, if each floor was 3.7 meters high, what was the winner's change in gravitational potential energy? So we're going to use the equation, change in UG equals mg change in y. The m is our mass, which is 60 kilograms. Our g is gravitational pull, which is 9.8 meters per second squared. There are 86 floors. The height of each floor is 3.7. So our change in y, which is the height of the building, is going to be 86 multiplied by 3.7, and we get 318.2 meters. And then, so our change in UG is going to equal 60 kilograms multiplied by 9.8 meters per second squared multiplied by 318.2 meters, and we end up getting 1.87 times 10 to the 5th joules, or approximately 190 kilojoules. And then part B reads, if the efficiency in climbing stairs is 25%, what total energy did the winner expend during the race? So for part B, we have our efficiency is equal to 0.25, and we have our energy is equal to the change in gravitational potential energy over the change in the chemical energy, or how much they're using. And so our change in energy total is going to equal change in the gravitational potential energy over E. So we get 1.87 times 10 to the 5th joules, and then our efficiency is 0.25. So we end up getting 7.48 times 10 to the 5th joules, or approximately 750 kilojoules. And then part C reads, how many food calories did the winner burn in the race? So for part C, we have 1 capital C calorie is equal to 1,000 lowercase c calories, and then 1 lowercase c calorie is equal to 4.19 joules. And so we're going to convert our food calories to joules. So we get food calorie, or capital C, is equal to 1 capital C calorie multiplied by 1,000 lowercase c calories over 1 capital C calorie. And then we have 4.19 joules is equal to 1 lowercase c calorie. And once we convert that, we get 4.19 times 10 to the 3rd joules. Okay, so the amount of energy in 1 capital C calorie is 4.19 times 10 to the 3rd joules. So now our energy total that the racer burned is the 7.48 times 10 to the 5th joules that we found in part B, multiplied by 1 capital C calorie over 4.19 times 10 to the 3rd joules. And so we get that the racer burned 180 calories. And then part D reads, of those calories, how many were converted to thermal energy? So our change in thermal energy is delta E thermal is the absolute value of E chem, which we used in part B, subtracting the gravitational potential energy. So our E chem was 7.48 times 10 to the 5th joules. And then our change in gravitational potential energy we found in part A was 1.87 times 10 to the 5th joules. So we get 5.614 times 10 to the 5th joules. And then we need to take that and convert it back to calories. So we're gonna take 5.614 times 10 to the 5th joules, and we're gonna multiply it by 1 calorie over 4.19 times 10 to the 3rd joules, and we get 133.985 calories, or approximately 130 calories. And then part E reads, what was the winner's metabolic power in watts during the race up the stairs? And so to do that, the time was 649 seconds, or 10 minutes and 49 seconds, and the equation we're going to use is power is equal to delta E chem over time, and delta E chem we found in part B was 7.48 times 10 to the 5th joules over 649 seconds, and we get 1,153.158 watts, or approximately 1,200 watts.